Alright, so let's finish this problem. We're looking for the number of three-digit numbers that are multiples of 7. So we're looking for multiples of 7 between 100 and 999. And we found the first one. So all we did was we took 7 times 10, that's obviously a multiple of 7, and we added a multiple of 7, which is 35, to it to get 105. And that would be our first multiple 7 in the list. And anytime you take a multiple of 7 and add 7 to it, it's automatically going to be divisible by 7. So if you add a multiple of 7 to it, then it's also going to be a multiple of 7. So if we add 7 to this, the next number in the list will be this plus 7. So we have 112. And if we add another 7 to it, we get 119. And so on. And now we need to find the biggest three-digit number that's a multiple of 7. So let's just work with adding multiples of 7 here. So I know if we add 700 to that, that's a multiple of 7. You get 805. So that has to be a multiple of 7. That's not quite big enough, though. We can add more. If we add 140 to it, because 140 is obviously 20 times 7, we get 945, which has got to be a multiple of 7. All right. I got to put those plus signs. Okay. So we're almost there. We're 55 away from 1,000, so we got to add something less than 55. So a multiple of 7 that's less than 55 would be 49. Right? So if we add 49 to it, we get 994. And if we add 7 more, we'd get 1,001, which is too big, so our last number is 994. Okay. So now we've converted this how many three-digit numbers problem into a how many numbers are in this list problem, right? So this one's a little bit different from the ones we've seen previously. In the ones we've seen previously, the gap between the numbers is 1, right? But in here, the gap is 7, right? So we're adding 7 each time. So the temptation might be just to subtract 104 from everything, and then you'd get 1, but the next number would not be 2. You'd still have a gap of 7, so the next number would be 8. So the first thing we want to look at is figure out how to close that gap before we shift everything to 1, okay? And that gap indicates that there's a multiple of 7 involved, okay? So if the gap is 7, then every number in the list is the first number plus some multiple of 7. And so the advice I would have for you is look at the gap. And you can't just look at the first gap, because some lists, like for example, if I had a list of 1, 4, 9, 16, 25, 36, and so on. Now you can see if the first gap is 3, the next gap is 5. So the gaps aren't even. So be careful. You know, make sure that your pattern actually establishes that the gap is constant. And anytime you have a list of numbers where the gap between the numbers is constant, that's called an arithmetic series. And there's some special, I've got some other neat tricks you can do with arithmetic series that I'm going to post soon. But make sure you check that. Check the gap between the numbers and make sure that and if that gap is constant, then you can need to figure out how to close that gap. In this case, if the gap is constant, that just indicates that there's a multiple of 7 involved. All right, so every number in this list is the first number plus some multiple of 7. And in this case, we can just divide by 7 to close the gap, right? And then we'll get 15, 16, 17, and so on. And 994 divided by 7 is 142. All right. So now we have a list of numbers where the gap between the numbers is just 1, which makes it a lot easier to work with, because now all we have to do is subtract 14, and we'll get a list that looks like 1, 2, 3, and so on, all the way up to 128. And that's our answer. So there's 128 numbers in that list. And that's a heck of a lot easier than trying to list them all out and count them. All right, so this is kind of a handy trick. So let's look at this next list. All right, so like I said, look at the gap first. Here we have a gap of +3. Here we have a gap of +3. Here we have a gap of +3. So again, we've got an arithmetic series. And in order to close that gap, we've got to divide by 3 somehow. But in this case, the numbers are not divisible by 3. You can't divide 35 by 3 and get a whole number anyway. So we need to figure out how to shift this to make it divisible by 3. So what if we just, well, we could add 1. That would do it. Let's do that. That's easy. Add 1 and you get 36, 39, 42, and so on, all the way up to, let's see, 69. And those are all divisible by 3. So we can then divide by 3, and we'll get 12, 13, 14, all the way up to 23, correct? And so now we've got a list where the difference between consecutive numbers is 1, so we've got a counting list, and then so now we just need to subtract 11 from it, and we'll get 1, 2, 3, all the way up to 12. All right, so there's our answer. Pretty cool, huh? And the last example I want to do is this one. This is a trickier one. Here we've got a list that involves fractions, okay? And but again, well, let's first of all, since these are mixed numbers, let's convert them to improper fractions, because it makes it a bit easier to see how many fifths you're working with each time. So we have 1 and 4 fifths, 2 and 1 fifth, 2 and 3 fifths, and so on. But it's a lot easier to see what you're doing if you convert this to a mixed improper fraction first. And so this would be 9 fifths, right? You just take 5 times 1, so that's, and then add 4 to it, so that's 9 fifths. And then we'd have 11 fifths. And here we would have 13 fifths. Oops, 13 fifths. And all the way up to, let's see, that's 150 plus 3, that's 150 fifths. Oops, sorry, 153 fifths, because we got to add that 3 to it, right? 153 fifths, okay? So now it's a little easier to see what we're working with, and you can see that we're just adding 2 fifths each time, right? So, first thing, I don't like working with fifths. Let's just multiply everything by 5 and get rid of the fractions altogether. Makes it a lot easier to work with. So then we have 9, 11, 13, all the way up to 153, okay? And the gap between those numbers is 2 each time, so we want to somehow divide this by 2, but the numbers aren't divisible by 2. So let's, we could subtract 1 from each one. So then we get 8, we get 10, we get 12, all the way up to 152. Now we can divide all those by 2, and we get 4, 5, 6, all the way up to, what would that be, 76, right? And then we can shift it now, because all of the the difference between the numbers is 1. So now if we subtract 3, we'll get 1, 2, 3, all the way up to 73. All right, and the answer is 73. Okay, so do the worksheet and and practice this, and it's a very handy trick for counting numbers without actually listing them out and counting them.